Colleagues, ladies and gentlemen, welcome to the Faculty of Engineering Distinguished Lecture. There's no denying today that global warming and climate change effects will have extremely negative impacts on our environment and the way we live. Sea level is going to rise and threaten the livelihood of millions. The release of the IPCC report is the latest wake-up call, which is one that we cannot snooze on. And this is something that requires concerted effort of all nations. This morning, Professor Yan will explain how technology plays a critical role in reducing greenhouse gas emissions and increasing greenhouse gas sinks. He will highlight a combination of actions and focus on the practical technology options that will help make the difference in our efforts to reduce harmful greenhouse gas emissions. Now, the potential impacts of the integration of greenhouse gas mitigation technologies to the climate policy will also be discussed. And so, let me introduce Professor Yan briefly, our distinguished lecturer this morning. Professor Yan is Chair Professor of Energy Engineering at the Royal Institute of Technology, or KTH for short, and Malardalen University, Sweden. He came to Sweden from China in 1989. This is one clear sign of important talent, something that we ourselves have been doing, started to do in the last few years. Now, during 2001 and 2005, Dr. Yan was Chair Professor and Head of the Energy Engineering at Luleå University of Technology, Sweden. Professor Yan is well known, being Editor-in-Chief of the international journal called Applied Energy, published by Elsevier, and he is conference chairman of numerous forums, and the most significant in the recent years is the International Green Energy Conference. In fact, the next one, Green Energy Conference 4 in Beijing, he's chairing that. And he's also chairing the International Conference on Applied Energy in Hong Kong, January 2009. Co-chair, he's also on the editorial board of several journals, too numerous for me to name. And more interestingly, he serves as overseas assessor of Chinese Academy of Sciences, roster expert to the UNFCCC CDM, advisory expert to Asia Development Bank, and many other international organizations. It is my pleasure this morning, and on behalf of the Faculty of Engineering Distinguished Lecture Series, to welcome Professor Yan, and may I call upon him to deliver his lecture. Thank you.
Maybe I should stand here first to give thanks to your introduction, and it's really my pleasure to come to Singapore. That's the first time I come here, and I think I switched. That one is easier to talk. Can you hear me? Yeah, I hope we can start discussion rather than myself talk. And what my topic today is going to tell you a lot more about climate change technology and systems. And it's not pure technology. It's always climate change has been linked to the policy and some other issues. And as Professor Rose tell you, it's I'm working at the two universities, Royal Institute of Technology and Malardalen University, which one is Stockholm-based and another one is in Västerås. And how much you know Sweden? It's a small country, and here you have the world map, and it's in quite north. It's in Scandinavia, and I think I can use that one here. I just collect some data to compare with Sweden and Singapore, and it's very interesting. I found it's quite we have the similar GDP per capita of 39,000 US dollar per capita. But if you look at the other, sorry, it's some words in Chinese because I was giving a lecture in China, so I prepared something in Chinese. And the population is roughly 9 million, is roughly double as Singapore. And the density in local area is 415,000 square kilometers, which is that's quite large. And then if in terms of the density of the per square kilometer is 22 people, it's really, we really save very few people in Sweden. And it's quite covered by forest, and that's why the day after tomorrow I'm going to talk about bioenergy, because basically the forest industry is one of the major industry in Sweden. And the distance roughly from here, from south to from north to south, roughly is nearly 2,000 kilometers. And from the west to the east, roughly 400 to 500 kilometers. So I'm working here in Stockholm, and there's another. Oh, that's good. I didn't know they have Chinese name here. The Västerås, another university. It's the lake which has been linked to this area. And in Stockholm, it's roughly 1.8 million people. And I think Sweden is very bad to PR compared to company. They have a lot of this international company. Maybe you heard some of the company, but never you didn't hear it. That's or some has some origin from Sweden. We have been working a lot with ABB, for example. That's automation and energy related company, and some other company. Maybe you saw the Volvo. That's the car manufacturer, and there are more companies. That's the why I came to Sweden in '89. I really learned a lot about Sweden, how the innovative system has been established, and that's including our research. We just had a little bit chat with Professor Cho regarding the research, and we have been not really working on the pure classical engineering study, rather than we're working with technology, and at the same time we have working with policy and those issues. This is more like recently has been created a so-called new research area. You don't focus on the one pure classical area. And what I'm going to talk about today is a little background information about the climate change, and it's related to the CO2 capture and storage. That's one of the technology has been put really important position. And then it's regarding the negative CO2 emission system. You may not heard about that. That's a new system what we have studied, and it's very interesting to share the information. And then how to integrate CO2 capture and storage with the Pulp and Papers Mills. Basically, that's a bioenergy system. And a very important one technology is so-called Black Liquor Gasification. That's we have been working a lot with technology development. And the background information, I'm not going through this. That's some publication we have had, which is the basic background information about the talk today. And as just Professor Cho mentioned about that's hot topics in Singapore. I took some picture last night. I arrived yesterday morning, and I don't like to go shopping, but I really like to go to the bookstore. And any city, any place, I visit the bookstore because I make some photos. From bookstore, what kind of hot topics, and can really find what society linked to the local society and what hot topics. And here is really, at first I thought there are many talking about how to become leader. That might be linked to the Asia culture, and how everything can be predicted, and some of those kind of a lot of regarding the economy and something else. And then just happened to find there's one special, like there are a lot of books. You say this is 6 degrees, and some girls' books, and really it shows. I'm not sure if this is one of the hot topics in Singapore. And let's say it shows evidence of the global warming. And there are some. I'm not sure if we have seen such pictures, and I would like to show it's really kind of the evidence to show how climate change has been changed. It's become warmer. And what we are scientists, we do this really serious study. We do the curve fitting. And then you show this is maybe you show this kind of curve many times. That's roughly one central. And when we start to use the fossil fuels, and then it's here. It's roughly one central. We start to use fossil fuel, and then really shows the correlation between the temperature, and I'm not sure if we connect to the fashion. And then if we look a little closer to this period, and then go a little bit further. Sorry, that's 1,000. That's roughly when we start to use fossil fuel, roughly 100 years. And then if you look at the history, it's really quite, the temperature has been quite very stabilized. And then it's, in recent years, it start to get unbalanced increase. So that's the trends. And then I'm not sure if you have how much you know about CO2 capture and storage. Here shows the one basic concept for the CO2 capture and storage, how linked to the climate change. I'm going to tell you a little bit later, because before we started, that's the conventional energy production, and you have, for example, natural gas or oil, and then you can produce by the power plant through the gas turbine, or even new technology like fuel cells and some others. And then you generate electricity that's used for our energy use. And then because you have CO2 emission, then you can capture part of CO2, and then you capture CO2, and then you can store in the, for example, like so-called geological formation, and which can be stored in the old oil field to have the enhancement oil recovery, or you can store in the coal mine. That depends on what kind of storage capacity, and you can capture more. Of course, it costs you more, and then you have the quicker speed. So that's to illustrate how the CO2 capture and storage work. And let's back to our main topics. And climate change and CO2 capture and those carbon, it's not just the policy issues. It's really linked to the business. And here it shows the European market, like in EU emission trading scheme. I was giving the lecture in beginning of 2004 in Hong Kong, talking about carbon trading and climate change issue. Very few people, except the professor from university. And just 1 year later, it's before Christmas in 2004. And we have organized a similar lecture in Hong Kong again. And suddenly I found a lot of people might be similar like today. There are many people from business, actually, from bank and from investor. And I don't know what happened, because I asked the audience why suddenly changed the audience. And the reason because the European emission trading scheme introduced the market, the carbon market. And then a lot of investors found, oh, this is a new opportunity to make money. And that's really a good thing. Whenever it is, right now we are reviewing how the European emission trading scheme, if it works or if it's good or bad. But it's a very good signal. You send signal to the investor. This is a new business, and it's really linked to the new business. And many of our students, they found a new job in the carbon trading market. They are engineering, educated for engineering, but they're working right now not only for the engineering and also for the investment. And that's basically, you see the two curves. One is because this is the end of last year, December. That's why its market value for the carbon value becomes zero. And there's another is still right now is roughly 13 euro per ton of CO2. That's the current the European emission trading scheme. And then it's because this is the market which has been introduced carbon trading. But for we do the technology development, what we should do regarding technology development and how to mitigate the greenhouse gas emissions. And you must have heard basically there are three technology options, and improving the energy efficiency, that's might be in short term the least cost options, and switch to the low carbon fuels, for example, like renewable energy. And third one, like mitigation, because basically you emit, you try to capture them and store, and that's CO2 capture and the storage. And let's look at one of scenario which we have been used for the European Emission, European Commission, and also the European Parliament to establish the policy and the regulation for CO2 capture and storage. And that's this scenario basically is made based on 2050. If you want to reach the 2 degree, you saw books talking about 5 degree. Actually, there are many chapters. 1 degree, what happened? 2 degree, and 6 degrees will be very, very dangerous for our human beings. And now we're talking about the 2 degrees scenario in the future. And what you can do, you have basically three options: energy efficiency, and renewable energy, and CCS, CO2 capture and storage. And it's very interesting, even for me, if it looks energy efficiency, it really many different kind of technologies, portfolio of technology, which can be included. So similar for renewable energy, you can include the solar, biomass, and some other renewable energies. But they have put the CCS as this is the one technology put into for the future option. And this scenario is generated basically is the least cost. It's for the future least cost option. It's not designed by the. It's basically this drawn by the model, and which has been generated the scenarios. And it's really you find this plays very important roles. We do work a lot with the efficiency improvement and also renewable energy, but the CCS is one of the very important technology should consider. Without that, then it's really you cannot reach the 2 degree target here, versus really in the future, 2050. And it become very important for the future. And that's another scenario which has been made by basically from the industry, how much you're going to pay. Here you can see the marginal cost for the CO2 capture, CO2 mitigation. Per ton of CO2, how much you're going to pay for the US dollars. And you do find as if from energy efficiency improvement, you get a negative, basically here you get a negative mitigation cost, because you do make money through the energy efficiency without at the same time you mitigate the CO2 emissions. And then you have the power sector try to get the switch, the fuel or some other options. And then you come to the, here is like industry fuel switch and the CCS, and become more expensive. And then this was transport fuels. Actually, this is the most difficult part. And that's also one reason we are working on the bioenergy in Sweden, because this is one part of the, might be most expensive option. We have to try to find a solution. So this is another scenario which, if we are going to reach the target for the 2050. And the basic concept for the CO2 capture and storage is, I will not go very detailed, but it's basically you can say it's what we call the post-combustion. It's like any carbon-based fuel. When you combust, you have CO2, and you capture CO2 at the end of the production. And then you have the so-called pre-combustion. It's basically you switch the fuel, and you have CO shift and have more hydrogen-based fuel. This here you can implement either gas turbine or fuel cells, and then you capture CO2 through this part. And then you have the so-called oxyfuel combustion. Generally, we have the conventional combustion process with air, and the problem is for the high cost for the post-combustion capture, because you have to dilute CO2 concentration. That's why if you combust with oxygen, then you have the much higher concentration of CO2. That is cheaper to capture. But at the same time, you introduce the air separation unit, because you need to separate the air to get oxygen, and then you introduce additional costs there. So it's basically a trade-off where you want to save the money and where you want to increase the efficiency. And the industry scale for the CCS commercial projects right now in the world is a lot of link to the oil and the oil industry. And you can find one, it's in Norway. This is the first, the CO2 capture project, which has been started very early, and it's a very successful project. Still, we use a lot of this for the monitoring and the experiments, and also some other lesson to learn from this project. And then there's a Canada, there's another project, and then in Africa there's the Shell did the third project. All those you can find is the link to the oil industry. And basically, they try to use CO2 to inject the oil field to enhance the oil recovery, to have the more oil to be pumped out. That's three major demonstration projects. And there's one which we are involved. That's the 30 megawatts oxyfuel pilot plant. But this is connected to the coal-fired power plant, which is the world's first demonstration project for CCS, and it's developed by the Vattenfall, which is a Swedish company, utilizing largest state-owned utility company. But they bought a lot of the power plant in Germany, so they are the second or third. And it was always have a company buy each other. I think right now they are the third largest utility company in Europe. The first is the EF, the French electricity, and second is E.ON, and the third one is Vattenfall. So they are built one demonstration project. Origin the pilot plant start operated should be operated, but it has some delay. If there are many of my students working on the project, and we're working together with them. And what they try to do is for the first coal-fired based demonstration project, and which is really, I think, quite important project right now, also looking at. And just 2 weeks ago, I was in Iceland and giving a lecture, and then I found US just released the new CCS project, and also the IEA. You can find a lot of information about IEA the CCS program, which has and we have been working several projects in Europe for the CCS. And conventional CO2 capture source, I mean, where we could capture CO2. And we're talking a lot about the oil industry and also the electricity generations. Basically, this is one part we are talking a lot. And then you roughly, each of them, this is roughly 29% of CO2 emission in the total greenhouse gas emission. And there are some like oil refinery and natural gas processing. I think that might be linked to Singapore. I'm not sure if it's, I don't know the storage capacity in Singapore, but the CO2 emission source exists. And the technology, which you can different levels, and you have the pre-combustion capture and the post-combustion. That's more like current available technology. And a lot of work has been studied, and for the R&D, for example, like including the chemical, physical solvents. This is the very technical part we are working on, and also some new process called chemical open combustion. And basically, they use metal oxide for the combustion process, and we have some project working on that issues too. And that is you find that a lot of work has been done related to the fossil fuel based. And there's one which has been overlooked, is the biomass energy system. And it's just by chance we have been working on this area, because we're working on CCS, at the same time working with bioenergy. And then as you saw from beginning, we tried to find least cost options. And then we say, well, how about we put them together with biomass and CCS, if that's possible to have the cheaper solution. And then it's found that it's quite interesting results. And let's go back to what's the challenge for the CCS. And one is the efficiency penalty. And if you look at, if for example like coal-based, if without CO2 capture, it's right now is roughly 14.4% of the best technology for the coal-based. But if you have the post-combustion or oxyfuel, roughly you end with 13.5%. That means you have nearly 10 percentage point of the efficiency penalty. The similar situation you can find IGCC or the natural gas based. So the 10 percentage point of efficiency penalty, that's one part we have to work on. And here's another picture shows how the low battery. Okay. Yeah. I guess I have to wait. Remind us to have break. But it might be a good time for us if you have any question to ask me. Then we can. I'm waiting for them to. Yes. I guess it's because here it's not on. I just put on. Yeah. Please, if you have, yeah. Basically it's nearly pure CO2 will be captured. That's why when you capture CO2, it's very dilute. It's something like, for example, coal-fired plant or natural gas-fired plant is less than 10% of CO2. Basically, you need to extract CO2. That's how we have the efficient penalty, because you need additional energy to get the CO2 as a pure CO2. No. That's not. You should store in if it's talking about storage. You need to store more than 1,000 years. Yeah, if they get emitted, then you don't have any net mitigation. So you have the guarantee it can be stored. That's the one issue has been raised a lot regarding the. That's the bad connection might be.
This is your computer?
Yes, my computer. Should be. I guess because because it might be here. Yeah. Not very. Let's see. Hopefully. Yeah, that's one question. A lot of questions have been raised. How secure the CO2 has been stored in. 6 version might be okay. Yeah, right. No optimized life. It seems to still not connecting.
It's connected.
Yeah. Here you see the sign. Yeah. Okay. Sorry. So it's really electricity is so important. We really on the energy, and at the same time we have to solve our problem with the emission issues, and that's another study which has indicates the efficiency penalty. I'm not going to too detail, but anyway, there's a roughly 10% efficient, 10% point efficient penalty we have to deal with. And here it shows the breakdown of the efficient penalty where the efficiency has been lost. And we have a different kind of technology. It really depends on what kind of CO2 capture technology you are going to use. And for example, like we're talking about oxyfuel, and you do have less capture efficiency penalty, but you have very high so-called CO2 compression and purification, and plus this oxygen plant. That's I'm talking about the air separation. Basically you change from the post combustion to the oxygen production part. And the cost, that's another issue, because one is we have the efficient penalty, and another is the cost, is the increase your cost of. Here, this is might be, we can say this is a baseline gas turbine combined cycle, which we have most used. I guess this might be major energy production in Singapore if you use oil or natural gas based, and which is have the capital cost roughly per kilowatt is roughly $500, and then you find all those kind of ways, different kind of capture option. You have much higher cost, and this can be might be, let's say, natural gas post you increase roughly almost double, and this is more than double. And I think I have another picture shows the cost of electricity. You transferred how per kilowatt hour, how expensive it will be cost, and that's the natural gas with no capture. That's the cost roughly, and then you increase with different kind of option. That's convert to the cost of electricity, and then it's talking about the. Now we're back to the market. For example, the CO2 awarded cost. Here you see the per ton of the CO2 awarded and how much US dollar. Right now, if you're looking about roughly the European emission trading scheme, roughly around 20 euro. If it says this about a little bit about 20 US dollars, and all the technology right now we are talking about is not compatible in the current market, because basically it's too expensive, and you implement such technology, basically you lost money if it captures CO2. Again, the CCS has not included into CDM, for example. There's another policy issue you need to solve. It's really a lot of risk, and that's the one issue we are working on with the European Parliament regarding how to establish the CCS regulation and the policy. And that's a really hot topics which have been, and we are talking about in European Parliament again to might be in the future to have this obligation. When you build new power plant, you have to have CCS and to be implemented, and that's dependent when you should start this kind of policy and regulation. So it's a lot of discussion right now. And for the transport, and basically you can use the pipeline transport, or you can even use ship, or this kind of transport. This has been basically technology is no problem. It's only the cost issues, and we have been working a lot with that. Talking about your question about what kind of CO2 is pure CO2. You're supposed to, if you come to the pipeline transport, you have to have like a dense phase liquid, which is over critical part. That's why a lot of energy has been used for the compression for CO2, and that's we are working on the very fundamental thermodynamic properties to look at what kind of, when you have the CO2, that's basically pure CO2, but in the real case there are no pure CO2. You have the impurity. When you add the impurity, and what situation will be changed. For example, we try to design as close as possible to the critical point to save the energy. But if you have impurity and the critical point will be shifted a bit higher, that means you come into the not in the dense phase, into the two phase change range. Then it will be, it's totally your system doesn't work. That's one we are discussing right now with the demonstration project. And storage is basically you can, most of the right now talking about the geological formations for the storage, and the ocean storage is same is that because basically environmental law not allowed to dispose anything in our ocean. That means they do have a very big potential for the storage, but it's not basically not possible to implement. And that then you come back to the cost issues, how to reduce the cost for the CCS, and in terms of the cost of electricity, and really find that will be transferred. Right now, the situation for natural gas, we have such a price, and for the coal-based, and you have different, and then you can find this add-on the cost. It's really who is going to take this, and if we want to implement CCS. And basically it's money transfer. That's why it's a new business. New business is not means when it's become more expensive, it can create a new business, and that's depend how the regulation, how the policy will be made. And I try to summarize a little bit for the different kind of cost for CCS, and it's a little bit too detailed. Basically, you can find roughly right now we have $14 to $100 per ton of CO2. That's the cost, current cost, and our European trading market right now roughly 13 euro per ton of CO2. But if it looks at the scenario for the future, and a lot of talking about $100 per ton of CO2 if we want to reach the target in the future. And this can be transferred roughly 2% of the GDP in the world total if we want to solve the climate change problem. And it's not so much money. Basically, it depends on how we distribute money and redistribute money to what. But that's if you accept this is the climate change we need to do, and that's money we have to spend. And we're working with so-called power generation with CCS. That's more integration, how to integrate with the CCS capture part and transport part and storage part together with the power generation part. And then you have different kind of fuel, and you can have the so-called multiple products or the power generation system. And now I come back to the one question I have raised from beginning. Most of our system have developed the coal-fired, natural gas-fired power plant because this is what we call the real greenhouse emission because we use such kind of fossil fuels. And then it's one question for the fossil fuel-based energy system is basically you can reach the near zero emission system. You reduce the emission, but you can never reach to the zero emission system. Lot of talking about the zero emission system, which is scientifically is not correct because you cannot reach 100% capture. But there's a very interesting system which we have the bioenergy system plus CO2 capture. We call the BLGCC, and that's resulting in a negative CO2 emission system. And how it works, and that's very interesting because basically we cross the zero emission system. That's the basic concept for the integration bioenergy system with CO2 is it's a bioenergy system if we're talking about bioenergy, and because in the whole cycle we treat it as a near zero emission system, and then capture CO2 basically can be applied to the biomass system. And it's a very interesting biomass system is one of the renewable energy which has carbon. No other renewable energy has no carbon element because for the solar and the wind and the ocean and the geothermal, there are no carbon which has been involved. And then we are talking about try to integrate there another benefit might be you can increase the carbon sink. Basically the forest and all those is a very good carbon sink, and that's why we look at the opportunity if this can be well managed, and that can be additional benefit. And then the last one, in fact, is the first one why we studied the CO2 capture storage together with the bioenergy system, is we try to find the least cost options. And there are some other benefits for the integration. And if we compare with the bioenergy system and the fossil fuel system, it's quite similar, which is that's one topic I'm going to talk about the day after tomorrow. Oh, sorry. Here you have the fossil-based system. That's what we are doing. You have the resource, and then you have conversion. You have products, and then you have basically that's the end product: heat, electricity, and mechanical energy. And almost in the same way, you can working with the bioenergy system. and in the same conversion system and distribution, and come to the same end products. But the difference is the carbon cycle is different, because here you have the carbon can have the carbon fixation because the forest and or the biomass-based origins of kind of plant. And that's why if you look at the carbon cycle, biomass has been treated as a CO2 neutral, because the biomass, when you grow up, is absorb CO2. And if you look at the technical system, how it looks like, and that's what we are doing, and a lot of biomass power plant and also pulp and paper mill have been used. You have the biofuels, and that can be feedstock to the power plant. And you have energy product, and then the basic CO2 has been absorbed by the forest and or the other biomass plant. And also we do the recycle for the ash, and because try to keep the soil and for the nutrition of the soil improvement. And then it's because you have CO2 here, and if you capture CO2, if you look at the whole system, we put the boundary as the whole system. That's negative CO2 emission system. And that's why we made the presentation for this technology system in 2001 in conference. Then just by chance, some other people, they're working with climate change. That's IASA, Austria-based, impact is UN-based institute, International Applied System Study Institute. And they found, oh, this is very interesting, and they put this our technology system into the climate change scenario. And then they found this is a very interesting system, because basically you don't have a zero emission system. And for the future, the climate change will go to the one direction. It's irreversible, because you will have if you continue to use fossil fuel, you will continue to have the greenhouse gas emissions, even you have the very aggressive CO2 emission mitigation. For example, you capture 19% of the CO2 emissions. That's most we are talking about. But still you have 10% of CO2 emitted. But if you have the negative CO2 emission system, that means the system, totally system will be changed. It might go to history, and that's one lot of discussion, and that's how we probably this kind of results in science, because of that, because this is a very interesting new technology. And then a lot of discussion coming again to the bioenergy system, because the bioenergy system usually too small to implement what CO2 capture and storage, because we are talking about the cost issue. And then we are working a little bit more for what kind of system we can implement for the bioenergy system. Then we found the pulp paper mill. Basically it's a larger bioenergy system which has been used. But most of we're talking about production system rather than energy system. In fact, it is a bioenergy system, which has been that current technology has been used. I'm not going to talking too much about chemistry and for the pulp paper mill. But you have the basic wood chips, and you have coking process, and you have white liquor, which is used for white liquor basically is we use for the pulp and paper production. And same time, because the cooking process you have black liquor, and there are a lot of energy content. And then right now situation is you combust it, so-called use kraft tolerance boiler to combust it, and then you have green liquor and recover, and then continue use white liquor and for the pulp paper production. This is basically a conventional system right now we are using. And then it's because you have combustion process here, basically you can recover a lot of energy. But it's because you use conventional combustion process, the efficiency cannot be high. You only can implement the steam turbine and not the gas turbine. That's why we introduced the Black Liquor Gasification process in that part. That's the conventional system I have mentioned. Is from the black liquor. You can have electricity and process heat, and steam turbine. That's the system has been used. And then you can implement in the gasification process, so-called black liquor gasification. Right now in the world, it's the world leading technology, basically the two switch technology. One is the Chemrec, another is the ABB technology, working for the black liquor gasification. And then it's if you capture CO2. Basically, this is the pre-combustion capture concept. And you have a CO shift, and then you have hydrogen-enriched gas and continue use for the either gas turbine, even the fuel cells can be implemented. That's depending on how the system. Then here you can capture CO2. And so that's the technical system. And we made a lot of simulation for the whole system, and I will not go very detailed. That's the whole system has working with this gasifier part and the air separation unit, and integrated with the combined cycle. And basically, we try to reach the higher efficiency and try to reduce the cost further. And that's the whole system integrated with the steam and also electricity. And then this current situation in the world, pulp paper mill still use a lot of electricity. And based right now, all the commercial technology, we have made a very intensive study in Sweden, and it can be self-supplied for the energy for the pulp paper mills. That's the efficiency improvement. And but the discussion about CO2 capture and storage integrated with the pulp paper mill is still under this discussion, because it's not has been widely accepted, because they always think this is most of them people think it's too small to capture. And this is the gasifier with the Chemrec Gasifier, and we have ABB gasification process. I'm not going to talk in too much about the technology, and that's the experiment and the demonstration plant we have used. And then it can be in the future. It's possible to implement pulp paper mill as the power generation system. And right now we have several projects working on what optimal system which you can produce power, electricity, and steam. At the same time, you can have different kinds of fuels. For example, ethanol and pellets. That's solid-based biomass energy products. And you can find some other like DME or the methanol as a biofuel production. And back to the question which has been raised regarding bioenergy is too small to capture for the implement of CO2 capture and storage system. I made a little bit survey for the Swedish situation, and then found out actually they have a rather big CO2 emission, which is over than 1 million ton of CO2 per year. This is nine pulp paper mills. But if you look a little bit detailed, if you look at the CO2 report, and they do have the very low emission because this is fossil fuel based. But it includes the so-called biomass based, then it's really a lot of this called green CO2 emitted. And then it's such over 1 million ton of CO2, they have 9 plants. This is roughly, if all together, put together, roughly 10 million ton of the CO2 per year. And Sweden has roughly 1/10 of the total pulp production in the world. If make simple calculation, roughly that's 100 million ton of CO2 emission potential can be captured, and that's really a lot regarding. We're talking about the demonstration project at the beginning. All these 3 demonstration projects is roughly 1 million ton of CO2 based, and here we just show like roughly 100 plants. If we make a simple calculation in the world, there's such a potential. And then there's some other plant which hasn't been. We are right now doing the study together with Brazil, and because of ethanol production, there you have almost pure CO2 emission, and there is another so-called negative CO2 emission system you might be implemented with a very low cost, because you capture almost a pure CO2 there, and here we have the high concentration CO2, but it's not pure CO2. So that's the system. How it looks like all different pulp paper mills where it is located. It's a very good location because here you see almost linked to the coast, and Sweden's the CO2 storage capacity roughly here, and that can be implemented like a ship CO2 transport. And there's another project. It's my student. He's working in consulting company working on how the source and the storage can be captured and what kind of infrastructure we should build regarding the CO2 capture and storage. And we have another project because right now the European Commission tried to working a lot with CO2 capture and storage, but they cannot work alone. They have to work together with other partners. And that's one project we're working together with China, so-called CCS China and the EU project. And China is talking about one project going to build in Tianjin. It's called Green Gene project. It might be, it could be, they might be quicker than our this Vattenfall project, because it seems that right now they have been in rather good pace, and even they start a little bit late. And I think my time is almost. That's the situation. I just showed them last picture and what it shows compared to the United States and China. You really saw this is green consumption has been overtaken roughly. That's I think it's not clear. I think 17th. Yes. And then you really saw the path, and we just saw Olympic, they have overtaken U.S. to be the world #1 of the gold medal. And but the trends, what we saw this here is the gap for the oil consumption. I really hope there will not happen those kind of situation. If it's really for all the energy resource and the supply and also energy security for the global is not possible to really work in such a way. And that's the one issue right now. We have a lot of discussion with China, and again I would like to look a little bit at this world map of CO2 emission for capital. And even we're talking about China, it's quite big, but still they was under the world average for per capita CO2 emission. Right now I think they are over the world capital. And what we are talking about in the future, if we want to reach the target to have 2 degrees, we're always talking about 2 degrees 2050. And we need 2% GDP to be used for climate change. At the same time, we have to, for capital CO2 emission reduction, we have to work a lot. That's all individuals have to working together. And we have to be in the level right now, as I think it's the India, the level which we have, should be below the world average. That's really very challenging target. That's why you have to have more aggressive CCS to be implemented if you really want to reach such a target. And then we're talking about the future energy business, and it was the climate change, really not just the climate change. And this is a study which had been made by the European Commission and with a lot of experts working on what's the future business. And now they're talking about what business, like business investment for the energy R&D. And then they have they use 2000 as a baseline and 2050 as a future, what's going to invest it from business sector, not from the government. And if you look at the CO2 capture, because the CO2 capture and sequestration is zero in 2000. I mean, from company, from business sectors. And but if you look at the 2050, then it's roughly will be 3 billion of the 3 billion euro will be invested. And then if look might be the number doesn't make too much sense, and we look the gas turbine, for example, that's a major power plant, power manufacturer which have been invest a lot, which is equivalent roughly similar like a gas turbine business. We are talking about 2050. I have another picture. I'm not sure if I have including for the government investment. And another issue regarding biomass power generation will be increased roughly double. That's the major 2 areas which we are working on right now. Of course, there are some other, might be you are interested in some others, like this kind of electrical and hybrid cars that will be increased. I think here it's quite a lot for some business. This is basically the benchmark has been made by the European Commission of what future investment from business. Okay, and then the last picture we have, actually, Professor Cho has mentioned about that's our network, and we have been working in the Green Energy Conference, and that's 2008 in October. We'll have another conference, and then I have a journal here, and in fact, Professor Zhou is in the editorial board. I come here, we're going to discuss about after 2009, might be going to 2010 in Singapore. Still question, and we're going to discuss. And the conclusion, which you can say is really the main challenge for CCS, the efficiency penalty and the cost. And that's linked to the might be some cost you cannot really reduce it because what you got you need to pay. And that's why it's a very what's the future situation for CCS really depends on how the policy going to make. But the scenario shows if you want to reach 2 degrees in 2050, and this is technology you have to implement. Without that, then we will fail. Might be we end with this, hopefully not 6 degrees. And then we have this negative CO2 emission system. It's a very interesting system, but the rule is still limited. We're talking about 100 million tons of the potential. In terms of the whole CO2 you need to capture, that's not so much. I think 15 gigaton we're talking about per year if you want to reach it in 2050. And that's, I'm talking about in Sweden roughly 10 million tons, and in the world it might be 100 million tons. And the Black Liquor Gasification technology, I haven't really talked too much about. This is one technology we have developed, and hopefully this will be result a little bit high efficiency and low cost solution for the negative CO2 emission system. So we will not end with just the concept discussion about negative CO2 emission system, rather than we try to implement technology to make this happen. Okay, thank you. If you have any question.
We thank Professor Yan for this illuminating lecture. We're now ready to take some questions. So if you have some questions, please feel free to raise your hands and walk to the mic on the left and right side aisle. Yes, over there. Thank you.
Hi, Alam Khurshid here from ATL. Prof. Yan, thank you for your presentation. The concern I have is that leakages have been asked before, but it still is a concern because when you talk about nuclear waste, people just talk about the concern about the leakage. CO2 maybe, I don't know how less disastrous it would be, but it still is a concern. Second thing would be that now the cost is pretty high, as you said, sequestration and all. But in case we still can manage to capture CO2 and use for sequestration now, but there would be a race of like a coal power station. I mean, the way it is really booming nowadays. So instead of conserving energy or limiting the energy usage, you give a wrong signal to the people who are really very willing to increase the energy usage and all. And transport is another one. Sorry, I'm just asking too many questions. Think of this LNG and LPG carrier. I mean, this we know very well. It is very expensive to really transport. If you compare this one with the CNG, compressed natural gas, still that technology is not really there. And even if it's there, it will be very, very expensive. Thank you.
I'm not sure if I understand your question. Is regarding the, for example, storage, which is the risk for the compared to nuclear waste. That's the, I mean, for the human health risk. That's pretty low. CO2 is basically, even you have pure CO2 emitted, and then you have atmosphere. We have quite low percentage. It's only for the long term. We are talking about more like long term stabilization of the CO2 emission, or the ppm, how much CO2 you captured, and you have to guarantee they have. There the monitoring. It's called. It's one CO2. One project has been run by the European Commission for the monitoring the existing right now the demonstration project, especially for this in Norway, and which has been indicated it's quite a good storage. And of course, it's because you talk about 1,000 years, and now it's just like roughly 20 years. And how you can guarantee this is based on 20 years experiments to for the 1,000 years. But this is similar like nuclear waste, and we are in Sweden is really that's one reason Sweden is discussing about to phase out the nuclear power, which of course that's the process always get delayed. The main reason because of waste, nuclear waste, but it's a little bit different issues. It's not the risk is more like climate change risk rather than the other risk. But nuclear waste risk is much it's a different kind of risk you have to deal with. And for the cost issue, and that's why it is a cost. It will be more expensive, and that will transfer at the end will be consumers, and that has been implemented. If I think it's possible to do it. This is not basically totally market-based system. Sweden has been, the world always talking about Sweden is the world #1 of the tax charge. I have another picture which show my home, the electricity bill. Basically, I pay tax roughly 17% tax. Another 13% is real electricity cost. This 17% which has been transferred green certificate, which means the electricity producer, you have to buy the green electricity from the grid, even it might be more expensive. And then is the CO2 tax. Based consumer, you have to pay the CO2. And the third is the energy tax. It's different. Bioenergy, there are no tax. And coal has a very heavy tax. In fact, in Sweden, biomass is cheaper than coal as energy. The reason not because its market is cheaper, is because the tax. It's heavily taxed. That's why it switched to the system. The day of tomorrow, I will show you how Swedish system has been changed from the oil-based to the biomass or the other non-fossil fuel-based system. This is really because the regulation and the tax system has been changed in such system. That's similar, like we're talking global issue. 2% GDP, the money, we need to collect it. And if those money will be used for climate change, we can solve the problem. So the problem is more complicated because this is not one country, the many countries have to be involved. I'm not sure if I answer your question. You still a lot of question.
My name is Vladan Babovic. I'm from civil engineering. I have a question with regard to one of the slides that you have shown, how much CO2 is being pumped, and I'm a bit puzzled whether this is industrially produced CO2 or... You
mean the demonstration project, or?
Just one before. This one. That one. The world map.
Okay.
Exactly. Now, there is an evidence that it's kind of ironic that the Southeast Asia currently Indonesia in particular is the third global producer of CO2, and not due to industrial activities, but due to the drainage of its peat soils. And as you know, peat soil is mainly composed of organic carbon. It is ironic because they drain peat swamps to convert it into a biofuel, palm oil plantations, therefore releasing estimates are 800 megatons of carbon per year without fires. If you add to this the means of clearing the forest, you add the fires, you come up with another 4,200 megatons per year, which brings Indonesia to the third place in the world after the United States and China. And I don't see it here at all because it seems like there is between 1 and 2.9. But what is really ironic, and this is what decision makers do not see, is that say, well, biofuel is great, fantastic, but actually the cycle of growing palm oils, converting it, even before we start producing energy and release it, the carbon is already in the soil, right? Or we release it. So why are we not looking in keeping the carbon where it is before? Anyway, if you have a comment on this.
That's a very good question. Actually, we do study for that. You are talking about this is first generation biofuels, and then there is the second generation which is more like we talk about forest-based, and there are the third biofuel generation. So talking about algae, there's a lot of study has been doing, and even like by ethanol, it's a lot of debate regarding food price, and those is something that might be not really very relevant because in media they would like to tell the bad story rather than good story to attract the readers, and but there's some serious study which has been indicated, for example, like U.S. this ethanol, basically corn-based ethanol production has a very roughly like a 20% CO2 emission reduction. But compared to the Brazil, where sugar based can be 70% of CO2 emission reduction. I haven't looked at the Asia part for the including what you have mentioned about that. That's one project we are working on with ADB to look at the bioenergy system, what really CO2 emission reduction. But those figures, which not including those, because this is the based IPCC, they have the carbon inventory calculation, but they have methodology. This is what they have calculated. It's not the carbon sink always more complicated, because this is linked to the carbon sink issues, and that's why this kind of the CDM project linked to the plantation is very difficult because the monitoring and the evaluation, the assessment become more complicated. But those figures which has not included such an issue.
Yes, I believe, Professor Yan, this map actually indicates the so-called human-related anthropogenic production.
Yeah, it's basically this is the whole CO2 emission you have produced for each country divided by the population as a per capita.
Yeah, and I think going forward, I think what you have raised really just strongly suggests that it is not possible to talk about bioenergy or biofuel without bringing in the question of forest and others.
Or
yeah.
environment in general.
Yeah.
I think there is a question here about Jeff. Thank you.
Thanks very much for your great lecture, Jeff Obard from Engineering and with A-Star now. Just like to ask a little bit more detail what you were talking about ocean storage. Geological carbon sequestration has been described to me as a little bit like how men like to do housework. When our wives are out, we rush around and we brush up the dust and we lift up the rug and we put the dust underneath and we put the rug down, hoping it doesn't come back.
Yeah.
So there is a risk. So what we're really talking about is carbon capture and utilization, which is where the biomass comes in, and bioenergy, which is great. I noticed in your talk you were a little bit dismissive about ocean storage. The oceans mop up a third to a half of annual CO2 emissions. And how much work is being done to accelerate the ocean pump to remove CO2? Surely that's a way forward.
It's right now very few people study that. That's we're talking about discussion about 5 years ago. The capacity is really huge because the ocean basically you can observe. But then they come to lawyers. So, sorry, this is not allowed. Basically, it's the international law. You are not allowed to dispose anything in the ocean. That's why this kind of study become less, and there's very few studies right now working on that.
Personally, I would disagree with that. I'm involved in a study right now in the Pacific Ocean exactly on this subject about removing CO2 using the biological pump. I just want to highlight the point that there's a great amount of potential there, and it's something that we should be looking at.
Okay, that's interesting. It's
that would be good for you to bring back to the EU when you sit down. And
we had this, the greenhouse gas conference every second year. They have a conference. This IEA, basically International Energy Agency, is not only in European Union and also including the United States and some others. And that's a discussion which we had in Kyoto. In fact, that's 4 or 5 years ago. And almost there are a lot of debates about the ocean. Technology, with local technology should work, but basically the lawyer just say, no, sorry, we have to deal with those issues.
yes, Jinyue.
This is Jinyue from Chemical. Oftentimes I have a problem with the bioenergy in the sense that, first of all, you say that it only solves like 1% or less of the problem, because scalability is an issue. I think even for your fairly successful negative emission example, I mean, it cannot be applied to solve the CO2 problem globally.
No.
So that's number one. Number two is, even though bioenergy actually assimilates CO2, but I'm a little bit concerned about the rate that it can assimilate. That means the way that we use energy, the way that we produce CO2 outweighs the way that the bioenergy can capture the CO2 back into the system. So I mean, to me, I find that the behavioral change is still the number one thing. That means people have to use less energy.
Yes, that's really, every time I give lectures, the last time I tell students, when you take a shower, try to use less time. It was young students. Yes, that's true. We do have one project working on the monitoring of the household behavior, how they change behavior to say this is a really great potential. That's also indicated in scenario for the energy efficiency, including that's not only industry efficiency improvement, that's including the behavior. But still, that's not sufficient. And it has become very popular, like in Sweden or in Europe, become so-called ecological consumers and consumption, which means you really think about to use less those kind of products to change the behavior. And that's really, I think, it's very important. And regarding the bioenergy, yes, like this similar question as he raised, how you look the whole system. It's not all bioenergy will be CO2 neutral. That's for sure. And second is not the bioenergy is just one part of the system which is somehow helpful to solve the problem, but it's not the solution to solve the global. That's exactly what we have found when we had this study, and we discussed with science when should publish. That's just before the COP. I could remember when it was during that time United States not put two arguments. One, the evidence was climate change. Second, it's too expensive. We should wait until we have a better technology. And because we have strong arguments talking about you cannot wait, because wait just means you cost you more in the future. And this is the one direction change. But if you have negative CO2 emission system, basically you can wait a little bit. Might be this one argument could be put into. But we have a study looks at the potential you should really look is not a huge potential. This somehow can be part of you should consider. That's the problem is there are many have been working with CCS has not considered at all for this negative CO2 emission system. That's why we are talking a lot. But not my position is not that this can be one solution can solve the climate change. Then the power plant, all this coal-fired power plant and the natural gas-fired plant, they will be happy because that's all left them to solve the problem. But basically, they have to solve the problem.
Yes.
Andrew Palmer, Civil Engineering. The chairman began by saying something has to be done. But leading on from your last answer, essentially nothing is being done. The politicians, of course, support research because that's very cheap and a displacement activity to avoid the need to do anything. So nothing's being done now, but maybe at some point in the future, some action will be taken, some real action. What do you think has to happen before we reach that point?
Well, I think that depends. For example, like if I'm in Sweden, I make the example like Sweden, and something has been done, at least in Sweden. In the Kyoto Protocol, we have the target. Sweden is a 4% increase of CO2 emission in 2008 to 2012. That's the target. And what our internal, that's the government has been put like a 4% negative minus. That means we have 8% and even better than the Kyoto Protocol, the target. And right now, I think we will reach the target. But that has been done basically if without any new regulation, without any those new instruments, and including tax and green certificate, that's almost impossible to reach. And if basically are just like a market-based least cost option without any new instrument, then the basic submission is possible. That's the case. And the problem is that we come to the global issue is really quite a challenge. I agree with you. It's really some people say always like, okay, you do the better job. I try to do they're always a free rider and try to take the benefit. And that's the problem which I had to. I really don't know. I don't have a solution, but we try to work in more like a technology development and try to work together with the government to say what kind of policy or regulation which can support such a kind of development. But it is very challenging, and I agree with you. It's a political talking rather than doing. There's a lot of such a kind of activities have been done. It's really very different from different countries. But I think the European Commission makes this quite serious, and that's why how emission trading scheme has been started, and they basically allocated all the CO2 quotation to each country. It's a little bit too easy to give the quotation, of course. That's the first lesson we learned. But then each country allocates all the quotation to the company. That's why how get into the industry get involved. That's similar lesson I learned at the beginning. We discussed with the Swedish industry before like 2004, and they are not interested. So, and now they need every year they need to do the reporting about their CO2 emissions. If they don't reach their quotation, they need to either pay the penalty, which is much higher than the emission trading scheme, or you go to the market to buy the CO2 credit. And that's why how the system has started. I think still we are learning, but something has been doing, and really, but in the whole global issues, that's really quite challenge how to solve the problem.
Really, it's not so much that nothing is being done. It's a question of how much needs to be done, and how fast and how soon. In fact, some even believe that maybe we are too late.
Yeah, it is.
In some areas, yeah. Here in Singapore, we recognize the huge potential on energy efficiency improvement, and this is one area where we will be looking at very seriously. We are working with a number of agencies, to get a strong so-called definition and identification of areas in which we could put resources into R&D as well as implementation. In fact, earlier this month, you might have learned that the government set up a website called Sustainable Singapore, inviting the public to provide feedback and what can be done to so-called safeguard the future environment of Singapore as a city. And I think they have been receiving lots of interesting feedback, and government actually has promised that there will be a panel that will be set up to look at those interesting ideas and to identify areas where further work can be done, improvements can be made.
Yeah, just comments a little bit for that, because it's new business too. That's a lot of discussion in Europe talking about sustainable business, and that's really stimulated basically because climate change issues. It's not only the ecological production and and climate change. Really, I think this is the one awareness has been increased a lot. That's one part we have to working on.
Are there any questions from the floor? Well, if not, then please join me in thanking Professor Yan for this very interesting presentation.
Thank you.
Welcome. And we look forward to your next presentation in 2 days' time. Thank you very much. Thank you.
Thank you.
Hi, Jeff.